Prediction using supervised machine learning. Myself, Pratham Javalkoti, graduate rotational internship program, the Sparks Foundation. The problem statement is we need to predict the percentage of student depending upon his or her study hours. So the very first step to solve this is laying the foundations. So including necessary libraries, import pandas, import numpy, import matplotlib. Now importing the data set, so we have to create a variable. In that variable, I'm going to fetch the CSV file which is already uploaded on Jupyter. My data is equal to pandas.read underscore CSV link. So here the data frame will be created. So the data frame is created and now we ask the compiler to print the data frame. Head 5, that means the first 5 rows will be displayed. Okay, so these are the first 5 rows of our data frame. Now, visualizing the data frame, we need to plot the data frame on the Cartesian plane. So this plot method is passed in the code. Now matplotlib.pyplot.title arts versus scores. So this will be the title of the plot. Then X label will be hours. That means the data hours will be mapped along X-axis, and Y label will be scores. That means scores data will be mapped along Y-axis, and then we ask the Jupyter notebook to show that visualization. So we get this visualization. The above graph represents the correlation between hours and scores. In order to calculate the coefficient of correlation, we can write a Python script for it. So this is the coefficient of correlation. So X will be my data hours. That means whatever is present in hours, that will be our X, and Y will be the data present in the scores column. So now this is a variable which is going to store the correlation between X and Y. X is having the data, Y is having the data. So numpy dot corr coefficient. So this is the keyword through which we are going to find the correlation between the data of X and Y. So print ROH. So this will show us. So correlation of X with X is 1, correlation of X with Y is 0.97, and so on. Correlation of Y with X is 0.97619066, and correlation of Y with Y is 1. So now we need to prepare the data. Here we create the input and output. Input will be hours attribute and output will be scores attribute, as well as we are guessing the score on the basis of hours. Right, so input will be our hours attribute and output will be the scores attribute, which is our target variable. So X will be my data dot I location. Okay, so -1 indicates that the second last column will be selected. Okay, that will be dot values. That means the second up till second last column of our data frame, those all columns will be selected and those will be stored. That data will be stored in X. So Y equal to my data dot I location 1. So 1 indicates the last column. So this will be my output. Y will be my output and X will be my input. So now we have input as X, which is our hours attribute, and Y as our output, which is scores. We need to split the data in terms of training data and testing data by using inbuilt method. So now we need to split our data whichever we have created in X and Y as our testing data, and then in order to check the model that we have created, we need testing data as well, training data and testing data. From sklearn.model underscore selection import train test split. So this is a method which is already inbuilt in this sklearn package. So X underscore train comma X underscore test comma Y underscore train comma Y underscore test is equal to train underscore test underscore split XY test underscore size is equal to 0.2. That means 20% of data will be utilized as test data and remaining 80% of data will be our training data. So random underscore state is equal to 0 indicates that. So this split is going to be constant. Whatever split we do and whatever data we get after splitting, that will be constant as the testing data and training data. So training the model, here we train the machine learning model with the help of training data and algorithm. So now we have the training data and we have the algorithm as well. So from sklearn.linear model, so as we have seen that there is a linear relationship between our x and y, so we will be including linear underscore model, import linear regression. So using linear regression method, we are going to build our model. So model will be is equal to linear regression. So model dot fit. Now we will be fitting our x underscore train data and y underscore train data. So now our model is ready. Okay, now calculating slope and intercept. So as we all know that linear line is y is equal to mx plus c. So here y will be the output whereas m is going to be the slope, x is the input data and c is the y-intercept. So we need to get the slope and intercept. So here print model dot coef underscore. This will give us the slope of that linear line on the graph and intercept. So print model dot intercept underscore will give us y-intercept. So the values are displayed over here. Now representing the line of y, formula y is equal to mx plus c. M is going to be the model dot coef underscore and c will be our model dot intercept underscore. So our line, okay, so y is equal to mx plus c. So we have to write it in that form. Line will be equal to model dot coef underscore into x plus model dot intercept underscore. So matplotlib dot pyplot dot scatter x comma y, matplotlib dot pyplot dot plot x comma line. Now we are asking it to plot for us, and matplotlib.pyplot.show, we are asking it to show. So this is the line along which our prediction is going to be done. Now testing the model, our model is ready, we need to test it. So here print x underscore test, that means this is our testing data. So y underscore predicted is equal to model dot predict x underscore test. In order to predict something, we have to initialize the variable, and using model dot predict and sending in the data in the parenthesis, we can get the prediction. So print y underscore predicted. So these are the predicted values. If we compare these predicted values with the actual values, we will be getting the comparison over here. Those are quite close. So evaluating the model, in evaluation of the model, we need to evaluate the model depending upon the accuracy and mean absolute error. From sklearn import metrics, from sklearn.metrics import r2 underscore score. So metrics will be giving us the mean absolute error, and this method r2 underscore score will be giving us the accuracy of the model. So accuracy will be fetched through r2 underscore score. So it will be calculated using this method, and error will be calculated using metrics.mean underscore absolute underscore error by passing in the testing data and predicted data. So we get the accuracy as well as the mean absolute error. Thank you.